In this session, we will discuss speed time graphs. Yesterday, we discussed the distance time graph and we calculate the speed from a distance time graph. Today, we will discuss speed time graphs and explain the motion by using a speed time graph, as well as we will calculate the acceleration and the distance by using these speed time graphs. So first one, for a speed time graph, it, different cases are there. The first one, when object is at rest, when object is not moving. So if object is not moving, what should be the speed of the object? If object is stationary or object is not moving, the speed of the object should be 0 meter per second. So when we sketch a speed time graph for an object which is at rest or object which is not moving, example, this is an object and it is stationary or it is at rest. So if it is at rest, what is the speed? The speed will be 0 meter per second. It does not move. So when we label the axis, y-axis speed and x-axis we have time. So after 1 second it will be 0, after 2 seconds it will be 0, after 3 seconds it will be 0, after 4 seconds the speed will be 0. So when we draw the line, it will be on the x-axis. So whenever for a speed time graph, the line is on x-axis, the horizontal line, it shows that this object is stationary or this object is not moving. Is it clear? The first case for a speed time graph, when object is at rest or object is stationary or not moving. Because for object to be stationary or object to be at rest, it should not move, so the speed should be 0. The second case, when object is moving with a constant speed or uniform speed, so what should be the shape of the graph? It will be a horizontal line. How we draw this graph? So example, this is an object which is moving with a constant speed or speed is not changing. All the positions it is having a same speed. And these are the time intervals. Example, this is a beginning, so time is equals to 0, 1 second, 2 seconds, 3 seconds. And speed of the object, example, 4 meter per second, 4 meter per second, 4 meter per second, and 4 meter per second. So when we sketch a speed time graph for this object which is not moving or which is stationary, which is moving with a constant speed, sorry. So when we label the axis, so this is time is equals to 1, 2, 3, and 4. And on x and y axis we have speed. So speed, example, this is 2 meter per second, then 4 meter per second, and then 6 meter per second. So in the beginning the speed is 4 meter per second. After 1 second it is 4. After 2 seconds it is 4. After 3 seconds it is also 4. And after 4 seconds it remains 4. So when we join these points to show the motion of an object by using a speed time graph, so what we will get a horizontal line, but this time the horizontal line will be above the origin, which shows that this object is moving at a constant speed, or we can say that this object is not having any acceleration or not accelerating. So this is moving with constant speed, or you can also say no acceleration. Because acceleration refers to change in the speed. If there is no change in speed, there is no acceleration. Is it clear? Saim, Abdullah Khan. Yes, Abdullah Khan. Next is when object is moving with a uniform acceleration or constant acceleration. So what will be the shape of the graph for a constant acceleration? It will be a straight line with a constant slope starting from origin, the line. And how we explain this motion, the constant acceleration. So we have an object which is moving towards right hand side. This is when time is equals to 0, 1 second, 2 seconds, 3 seconds. And this object is moving with different speeds. Speed is changing, but the change in the speed is constant. Like example, in the beginning, it started with from rest. Then after 1 second, its speed example is 5 meter per second. Then after 2 seconds, its speed is 15 or 10 meter per second. And after 3 seconds, its speed is 15 meter per second. So this object is having a constant acceleration. How we can work out the acceleration? Acceleration refers to change in velocity. So rate of change in velocity. So when we calculate the acceleration from A to B, so from A to B, it will be 5 minus 0 divided by 1, which is equals to 5 meter per second square. When we calculate acceleration from B to C, the change in the velocity from B to C, it's 10 minus 5 divided by time interval. So it will be 2 minus 1, which is equals to 5 meter per second square. And from C to D, the change in the velocity, that's 15 minus 10, and the time interval, that's 3 minus 2. So it will be 5 divided by 1, that's equal to 5 meter per second square. So you can see the acceleration is same for all the parts. There's a constant acceleration, but the speed is increasing. So when we sketch this graph, or when we plot this graph, to explain the motion of an object, a speed time graph for an object which is having a constant acceleration. So we have time on x-axis, we have speed on y-axis. So 1, 2, 3, 4, 5. And example, this is 5, 10, 15, and then 20. So till at after 1 second the speed was 5. So 1 second the speed was 5. After 2 seconds the speed is 10. So 2 seconds the speed is 10. After 3 seconds the speed is 15. So when we join these points, so it will be a straight line with a constant slope or constant gradient, which shows that this object is having a constant acceleration or same acceleration throughout the motion. Is it clear? the graph for constant acceleration. Then it can have a non-uniform acceleration, like acceleration might increase or acceleration might decrease. So for a non-uniform acceleration, so two possibilities are there. Number one, the acceleration might increase. Number two, the acceleration might decrease. So if its acceleration is increasing, so how we can show the motion of an object for increasing acceleration? So the motion of an object at this point, say this is when time is equals to 0, the object is start to move. When time is equals to 1 second, time is equals to 2 seconds, and time is equals to 3 seconds. The speed of an object at this point example is 0 in the beginning. At this point it is 5 meter per second, then it is 12 meter per second, and then it is 20 meter per second. So when we calculate acceleration for A, B, so for part A and B, the acceleration, because acceleration is a change in velocity divided by time interval. So when we calculate the acceleration of an object from position A to position B, so from A to B, what about acceleration? Change in velocity, that is equals to 5 minus 0 divided by time interval equal to 1. So that acceleration will be equal to 5 meter per second square. So acceleration from A to B is 5 meter per second square. When we calculate the acceleration from B to C, so the speed at B is 12, C is 12, and speed as B is 5. So when we calculate the acceleration, it will be 12 minus 5 divided by time interval. So interval, because at B it is 1 second, and c it is 2 seconds, so time interval is again 1. So 12 minus 5, that is equals to 7 meter per second square. And when we calculate acceleration from c to d, this object is accelerating, and acceleration from c to d, so it will be 20 minus 12 divided by time interval, that's equal to 1. So it is equals to 8 meter per second square. So you can clearly see that the acceleration of this object is increasing. First it was 5, then it is 7, and then it is 8. So how the graph will appear for this type of motion in which the acceleration is increasing, the speed time graph, for increasing acceleration, the slope or the gradient will increase, so it will get steeper. And if acceleration is decreasing, how we explain the term acceleration is decreasing? Even though the speed is increasing, but acceleration, the change in velocity in a unit time will decrease. Example, here it is 0 meter per second, then it is 5 meter per second at time is equals to 1, then it is 9 meter per second, when time is equals to 2, and then it is 13 meter per second or 12 meter per second when time is equals to 3. Now if we want to calculate the acceleration from A to B, so when we calculate acceleration from A to B, what is the acceleration? The change in the velocity, that is 5 minus 0, and the time interval, this is 0 second and 1, so time interval is 1. So initial acceleration is 5 meter per second square. What about acceleration from B to C? The change in the velocity, that is 9 minus 5 divided by time interval is 1. So acceleration from B to C is 4 meter per second square. And when we calculate acceleration from C to D, the change in velocity 12 minus 9 divided by 1, so that is equals to 3 meter per second square. So even though the speed is increasing, but the change in the speed is decreasing, that's why the acceleration is decreasing. So the graph which explain this motion, what will be the shape of the graph? The speed time graph. This is Abdullah Sarfar's new topic, which is speed time graph. Yesterday we did distance time graph. Today we are discussing speed time graph. So speed time graph for an object which acceleration is decreasing. So what will happen? The curve will be with this, the angle will decrease or it will get less steeper. Is it clear about the acceleration? Because using a speed time graph we can work out acceleration. Is it clear to everyone? For those who join late, just a quick revision for speed time graph. So for a speed time graph, if an object is at rest, or object is stationary or not moving, so what will be the speed time graph? Because when object is stationary or object is not moving, means its speed is 0. So how we represent the speed is 0? So we draw a horizontal line on x-axis which shows that this object is stationary or this object is not moving. If object is moving with a uniform or constant speed, or you can also say no acceleration or no change in speed, so the value of the speed should not change. And how the speed time graph will appear: on x-axis we have time, on y-axis we have speed. So the speed of an object is not changing and there is no acceleration for object. So what will be the shape of the graph? It will be a horizontal line which shows that the speed is constant or speed is not changing, and whenever the speed is constant it means the object is not accelerating. And the third case, when object is moving with constant speed, constant acceleration or constant change in the speed. So what will be the shape of the graph? If we have speed and time, so this is representing the constant acceleration, so it will be a straight line. For part B, if acceleration is increasing, so we use a speed time graph. How we represent a speed time graph for increasing acceleration? On y-axis we have speed, on x-axis we have time. So we draw a line and it is getting steeper, so it shows that acceleration is increasing. If acceleration is decreasing, so using a speed time graph, how we represent decrease in acceleration? On x-axis we have time, on y-axis we have speed. So to show a decrease in acceleration, the angle will decrease. And two more graphs are there for speed time. One is representing a constant deceleration. The term deceleration means the speed will also decrease. So an object initially moving at a higher speed tend to slow down. Example, this was 30 meter per second, then it is 20 meter per second, then it is 10 meter per second, and then it is 0 meter per second. A, B, C, and D. And the time, that's a start. Time is equals to 1, time is equals to 2 seconds, and time is equals to 3 seconds. When we calculate the deceleration, because when speed is decreasing we call deceleration, it is equals to change in the velocity divided by time interval. From A to B. So if we calculate a deceleration from A to B, the change in the velocity, at B the velocity is 20 and at A it's 30. So change is final minus initial, so final is 20 minus initial is 30. So 20 minus 30 divided by time interval. So from A to B the time interval, it's 1 second. So 20 minus 30 divided by 1. So deceleration will come out as minus 10 meter per second square. When we calculate deceleration from the deceleration from B to C, again the formula, the change in the velocity. So from B to C, at C the velocity is 10 and at B the velocity is 20. So 10 minus 20, why? Because it is always final minus initial, divided by time interval. At B the time is 1 second and at C the time is 2 seconds. So interval is only 1 second. So it will be 10 minus 20 divided by 1. So deceleration will come out as minus 10 meter per second square. And if we calculate a deceleration from C to D, so change in the velocity divided by time interval, so it will be 0 minus 10 divided by time interval is 1. So deceleration will come out as minus 10 meter per second square. So you can see the deceleration is same. From A to B the deceleration is 10, from B to C it is minus 10, and from C to D is also minus 10. So deceleration is same and the speed is decreasing. So how the graph will appear, the speed time graph for an object which is decelerating. So on x-axis you have time and y-axis you have speed. So time is equals to 1, 2 and 3, and the speed we mark, for example, 10, 20, 30. So when time is equals to 0 at the beginning, the speed was 30. So we'll get a point. When time is 0, speed is 30. When time is 1, the speed is 20. So time is 1, speed is 20. When time is 2, speed is 10. And when time is 3, the speed is 0. So when we join these points, it will be a graph, a straight line graph. So it will be a straight line graph which represents different points and shows that this object is having a constant deceleration. Is it clear? So when distance time graphs are there, we use the term speeds, and when speed time graph is there, we use the term acceleration. So if I summarize this and say explain the motion of the graph, explain the motion of the object by using the graph. So speed time graph is given. And three different sections are there for this graph: A, B, C, and D. So explain the motion from A to B. So what is happening from A to B? Speed time graph is given. What is happening to this object as it is moving from A to, it's a speed time graph. Speed time graph, speed is not constant, acceleration is constant here. Because speed time graph, when it is a straight line, it shows that is a constant acceleration. You have to, if it was a distance time graph, then it will be a constant speed. But because it is a speed time graph, what is happening from A to B? It is having a constant acceleration, not constant speed. If you write constant speed, then it will be wrong, because the speed is changing. Speed is not constant. You can see the values of the speeds are continuously changing or increasing. That's why if you write constant speed, that is not the right answer. Is it clear? The first part from A to B. Then motion of an object from B to C. So from B to C, what is happening? The value of the speed is not changing. When the value of the speed is not changing, we use the term constant speed or no acceleration. So what is happening from B to C? It is having a constant speed, or you can say it has no acceleration or no change in speed. So this, because it's a speed time graph, so basically what is happening from A to B, when the object is moving or traveling from A to B, the speed is increasing with a constant rate. This is a speed time graph. A speed time graph, the slope represent acceleration. So from A to B in a speed time graph, the motion, like example, if this is an object, yeah, why we are saying a constant acceleration? Because the acceleration is not changing from A to B. Example, at point A the speed was 0, then at point B the speed is 5, and at point C the speed is 10. From A to B we are calculating, so 3 points are there from A to B. So when we are calculating an acceleration, acceleration is a change in velocity. So here 5 meter per second square, and this part also 5 meter per second square. So from A to B, the speed is increasing, but the change in the speed is same. That's why we use the term it has constant acceleration. But from B to C, why we say constant speed or no acceleration? So from point B to point C, the speed is not changing. Like example, speed was 10 meter per second, then the speed is 10 meter per second, and it continued to move with 10 meter per second. So what is the acceleration here? The change, the speed, that is 0. What is the change in speed? That is also 0. So when there is no change in the speed, we call acceleration is 0, or we can also say this object is moving with a constant speed. So whenever there is a horizontal line for a speed time graph, it means that the object is moving with a constant speed. And what is happening from C to D? So from C to D, this object is having a constant deceleration. Why we use the term deceleration? The term deceleration means that speed is decreasing, and because it's a straight line, so it shows that speed is changing or decreasing with a constant rate. Is it clear? The speed time graph for an object. So I'll share another link and continue this discussion.